Good morning, students. Myself, Vijay Shankar from BC Department, Sheffield Engineering College. Today also we are going to discuss about the inverse Fourier transformation examples. In the last class, we discussed the Fourier transformation example. Next, find the Fourier transformation of this given graphical representation. Now here also the slope is there from 0 to t. Up to this is the slope, and t to 2t, the magnitude is a only. So you get the two functions. For the first one, you can write the slope, the 0, 0 origin. Both the x1 and y1 is x1, y1 is both are the zeros. And at this function, the x value is a t and y value is a a. Means x2, y2. First write the slope equation. Okay. y2 minus y1 by x2 minus x1. What is the y2 here? Y2 is a, y1 is a 0, and x2 is a t, x1 is a 0. So it is a by t. Now you can substitute that in the equation. The y minus y1 is equal to a by t into x minus x1. What is the y? The x of t's equation. The x of t minus 0 is equal to a by t into x is a t variable, t minus 0. So x of t is equal to a small t by the capital T in the range of 0 to t. In the interval of 0 to t, x of t is equal to. Another x of t is that the x of t is equal to a in the range of t to 2t. So using these two equations, x of t, find the Fourier transformation of the given equation, given graphical representation. So x of omega is equal to, in the first integral, 0 to t, what is the x of t here? A t by t. A small t by the capital T e power minus j omega t dt plus another range is there t to 2t. Its magnitude is a, nothing but x of t e power minus j omega t dt. Now we can apply the integral. What is the integral? A capital T, the a by the capital T is constant there, and t into e power minus j omega t. So t into e power minus j omega t by minus j omega, and minus, we'll get here the e power minus j omega t by minus, already the minus into minus will get the plus, and again it is a minus, we get so minus j omega one time, and another time also you get the minus j omega, with upper limit is 0 and lower limit is 2. Okay, two times you get to apply the integral of e power minus j omega t. Okay, plus a is a common term here, and integral minus j omega t by j minus j omega, with upper limit is 2t, lower limit is t. Okay, that is equal to a by the capital T. Substitute the t wherever the small t is there here, capital T e power minus j omega capital T by minus j omega, and here 2 minus is a plus, see the minus is there, and j square is there, again the minus finally will become the plus, e power minus j omega t omega square 1. omega square plus, now substitute the 0, the t is there, 0, the third term becomes a 0, and the minus into minus is a plus, and already the minus is there, j square into j square is a minus, that becomes a plus one. E power j omega into 0, the value is a 1. Okay, plus a into e power minus j omega 2t minus e power minus j omega capital T by minus j omega. Okay, my dear students. Now simplify the equation. Simplify the equation. Multiplying with the t is there here. A into. Now I'm multiplying the t inside a into. T get cancelled here. E power minus j omega into capital T by minus j omega and plus a into t, the a is already common term is there, 1 by or e power minus j omega t whole divided by omega square into t, omega square into t plus here there is a 1 by, already I told that is a minus to minus is a plus, and j square is a minus 1, and here the minus is there is a plus, e power 0 is a 1, and here 1 by omega square is also there. 1 by omega square into t is 1 by omega square into t, and plus a whole multiplied with write this function as e power minus j omega t into e power minus j omega t minus e power minus j omega t whole divided by minus j omega. Split it as 2 parts. Okay, my dear students. Now simplify. So finally, e power minus j omega t by minus j omega is here. And e power minus j omega t by omega square. Either a into, multiply that a, or take the a as a common in the both the terms. A into e power minus j omega t by j omega, and e power minus j omega t, a into omega square by t, minus, here it is a plus only, my dear students. The value is a plus a by omega square into t. A by the omega square into t. And why it is a minus means, see, okay, something went wrong here. Whenever I can substitute the 0 is there, the lower limit definitely can get it is a minus here the term, and the minus already is there. Minus into minus is a plus, j square is a minus, and again it is a minus into minus is a plus. By substituting the lower limit, the value is a minus. That is right. Whole divided by, and here the minus. Got it, my students. Then a into e power, take the e power minus j omega t common here, a by minus j omega into e power minus j omega t can take as a common, another e power minus j omega t minus 1. Got it, my students, in these two functions. And here also you can simplify. Finally, we'll get next, if it is in terms of linear constant coefficient differential equation. The given function is a linear constant coefficient differential equation. Determine the frequency response h of j omega and impulse response h of t for a stable continuous time linear time system, continuous linear time invariant system categorized by the linear constant coefficient differential equation given as d square y of t by dt square plus 4 dy of t by dt plus 3 y of t is equal to dx of t by dt plus 2 into x of t. So find the Fourier transformation of this function. We know the d by dt of x of t, its Fourier transformation is j omega into x of omega. And second derivative is d square by dt square, the x of t, its Fourier transformation is j omega whole square into x of omega. Okay, my dear students. So for the first one, j omega whole square into y of t is there, y of omega. So j omega whole square into y of omega plus 4 into the derivative of y of t is j omega into y of omega plus 3 into y of omega is equal to d by dt of x of t means j omega into x of omega plus 2 into x of omega. They are asking it is a determine the frequency response h of omega. Frequency response h of omega is equal to the ratio between of y of omega by the x of omega 1. It's a transfer function, simply saying output by the input. So in the left hand side, the y of omega, you can take the common j omega whole square plus 4 j omega plus 3 is equal to, in the right hand side, you can take the x of omega is a common 2 plus j omega. So y of omega by the x of omega is equal to, so x of omega is multiplied with 2 plus j omega and y of omega is multiplied with j omega whole square plus 4 j omega plus 3. Now you can find the denominator roots. What is the roots here? 3 plus j omega plus 1 plus j omega. Multiply here. J omega whole square, 3 j omega, 1 j omega, 4 j omega, 3 into 1 is a 3. So we got the same. The y of omega is equal by the x of omega is equal to 2 plus j omega by 3 plus j omega whole multiplied with 1 plus j omega. So by using the partial differentiation expansion method, a by the 3 plus j omega plus b by 1 plus j omega. So now the equation becomes a 2 plus j omega is equal to a into 1 plus j omega plus b into 3 plus j omega. So directly can substitute j omega is equal to minus 1, j omega is equal to minus 3, or otherwise comparing the constants and the coefficients, 2 is equal to a plus 3b. And j omega coefficients you can compare, 1 is equal to a plus 3, or a plus 3, a plus b. Okay, my dear students. Now subtract these two functions, we get the b. 2 minus 1 is a 1, a is get cancelled, 2b, b is equal to 1 by 2. So b is equal to 1 by 2 means a is also 1 by 2. A is equal to 1 by 2. Okay, my dear students. Because A plus B is equal to 1, A is equal to 1 minus B, 1 by 2. So what is the function? Finally, we got h of omega is equal to the ratio between of the output by the input. A we got 1 by 2 whole divided by 3 plus j omega, and the B is 1 by 2 whole divided by 1 plus j omega. So it is in the form of A by 1 by A plus j omega. So h of t is equal to, in terms of the inverse Fourier transformation, we can apply 1 by 2 into e power minus 3t mu of t, and plus 1 by 2 into e power minus 2t mu of t. Got it, my students? H of omega is equal to A and the B is a 1 by 2, 1 by 2. If it is in the, you have to find out the h of t also. H of t is equal to 1 by 2 e power minus 3t by mu of t, and 1 by 2 into e power minus 2t mu of t. Got it, my students? So frequency response and the impulse response. Now determine the Fourier transformation of this given function is in impulse, the delta of t plus 1 plus delta of t minus 1, delta of t plus 1 by 2, and delta of t minus 1 by 2. So the Fourier transformation here, the x of t is equal to totally, the delta function means value is 1 only. The delta value is 1, and if it is shifted towards right side or the left side, the x of t minus t naught, the Fourier transformation is Fourier transform by using the time shift property, e power minus j omega into t naught x of omega. So what is that x of omega we are taking? That is a delta. Delta of t, what is the Fourier transformation? 1. So now the Fourier transformation of the first function, the x of t given 1 by 2 is whole multiplied with delta of t plus 1. What is the delta of t plus 1? Shifting of one sample to the left side. So its Fourier transformation is x of omega is equal to 1 by 2 into e power minus t naught value is 1 minus 1, nothing but is a plus j omega into x of omega, the value is 1. Because the delta of t is 1 only. Plus another function is delta of t minus 1. Means one sample is shifted towards the right side. Plus for this e power minus j omega into the value is minus 1. Here it is a minus 1 means the value is a 1 here. 1 into x of plus for the second one, third one, not the second, third one is the delta of t plus 1 by 2. So e power plus j omega into 1 by 2 into delta of t, the value is a 1, plus delta of t minus 2, t minus 1 by 2. For this e power minus j omega into 1 by 2, delta function, the Fourier transformation is a 1. So therefore the x of omega is equal to 1 by 2 into e power j omega plus j omega, and here it is a plus e power minus j omega plus e power j omega into 1 by 2 plus e power minus j omega 1 by 2. So everything has a by 2 is there for all the functions, whole divided by 2 and whole divided by 2. So e power jx plus e power minus jx by 2 is the cos x cos omega plus, and here also the 2 is there, e power jx plus e power minus jx by 2 is the cos omega into 1 by 2. So omega by 2. So x of omega is equal to cos omega and cos omega by 2 is a function. Got it, my students? By using these two properties, the Fourier transformation of delta function is 1, the Fourier transformation of the shifted function e power minus j omega t naught. Here the minus means the positive negative exponential. If it is a plus means positive exponential. Okay. Now another equation we have here, d square y of t by dt square and the root of dy of t by dt and y of t is equal to, in terms of the linear time invariant system in a linear differential equation. So d square y of t by dt square j omega into j omega whole square. For this Fourier transformation is j omega whole square into y of omega plus root 2 into, for the first derivative is j omega into y of omega plus the y of omega is equal to 2 into, this is the second derivative of x of t, it is also j omega whole square into x of omega minus 2 into x of omega. So take the common of y of omega in this here, the y of omega whole multiplied with the j square is a minus, so minus omega square plus j into root 2 omega plus 1 is equal to, here the x of omega you can take as a common, and j square is a minus, so 2 minus 2 omega minus 2. Got it, my students? And before that, here the x of t is equal to t into e power minus t mu of t. T into e power minus t mu of t. The x of omega is equal to. Got it, my students? X of omega is equal to. So t into e power minus t mu of t. Mu of t is a 1 by j omega. E power minus 2t is a 1 by 2 plus j omega. And t is multiplied means 1 by the 2 plus j omega whole square. 1 by 2 plus j omega whole square. Okay. For this here, the first one is showing as a d square y of t by dt square. I wrote this, the function is d square y of t. The first function here, omega square y of omega plus 6 into y of omega and 8 into y of omega and 2 into x of omega. What is the x of omega is 1 by 2 plus j omega whole square. Okay. Find the impulse response of the system and what is the response of the system if x of t is equal to t into e power minus t mu of t. And the third one is repeat the part A for a stable and a causal linear time invariant system. The first we can see the T for this minus 2 omega square, my students, here omega square 2 into omega square. So h of omega is equal to y of omega. Here the y of omega by x of omega is equal to, as of here, x of omega multiplication factor, you can take the common of 2 omega square minus 1 by denominator is minus omega square plus j into r root 2 j omega plus 1. Okay, we got this. Then h of omega is equal to, we can write it as two parts. two parts. One is 2 plus of the simplification, the omega square plus 2 root 2 j omega plus 1. You can write the factors of the denominator. The factors of the denominator here. After that, using the partial differentiation expansion, 2 plus both are otherwise here the omega square and omega square. Here the omega square and the omega square is there. In the numerator having the same order and denominator is also the same order. Then we get the 2 plus minus root 2 minus 2 root 2 j by j omega minus root 2 plus j root 2 by 2. Why it is the denominator having the minus b plus r minus spirit of b square minus 4ac, you can write to get the complex function. Okay, what is the inverse Fourier transformation of this function? 2 is there. 1, the Fourier transformation is a delta of t, and it is in the form of a constant minus root 2, 1 plus 2j, and 1 by a minus j omega, means e power minus a into t mu of t. What is the a here? Is a total function is a e. Similarly to root 2, you can take the common. Root 2 is taken as a common, e power minus a, 1 plus j. 1 plus j is a minus term. So similarly here also root 2 minus root 2 plus 1 minus root 2j, the e power minus at mu of minus at mu of. That is the third one. So what is the first one here? A term. Find the impulse response h of t. Impulse response h of t means here d square y of t by dt square is a minus omega square j omega, and 6 into j omega y of omega and 8 y of omega 2 into x of omega. So take the common of y, omega square 6 into j omega and plus 8. So take the partial fraction method. Find the roots of denominator, and 1 by a plus j omega e power minus 2t mu of t and e power minus 4t into mu of t. Impulse response. In this, the x of t is given as a t into e power minus t mu of t. Substitute here. X of omega is equal to 1 by 2 plus j omega whole square. Y of omega is equal to, find the response of this system is y of omega is equal to x of j omega, the x h of j omega. X is a 1 by 2 plus j omega whole square, and 2 by minus omega square plus 6 omega into 8. But the roots is y of omega is equal to, we got 1 by the 2 plus j omega whole square, and already we know the denominator roots is the 1 by j omega plus 2, and another one is j omega plus 4. So take the a by 2 plus j omega, 2 plus j omega, and the b by 2 plus j omega whole square, and c by j omega plus 2, and d by j omega plus 1. Find the a, b, and the c and d values to get the response of y of t. So here 1 by j omega plus 2, a will get the 1 by 4, and the b is minus 1 by 2 j omega plus 2 whole square, and c is a 1, and d is a 1 by 4, minus 1 by 4. Apply here 1 by 4, a plus j omega e power minus 2 into mu of t, and it is a square is there, e power minus 2 into mu of t, and multiply with the t, and cube is there. Cube means t square by the 2 factorial. T square by the 2 factorial is there. Means the 2 is also, you'll get 2 factorial, t square by 2, e power minus 2t mu of t, and minus 1 by 4 into e power minus 4t into mu of t. Got it, madam? By using the linear differentiation equation, we get to find the partial fraction method and find the constant values a, b, and c. And for these also, the same thing. Determine the differential equation of the input x of t and the output y of t of the s. Okay, h of omega is given. H of omega means y of omega and x of omega. Multiply this function. H of omega is given this and write the factors of the denominator 2 plus j omega and 3 plus j omega here, and h of t will get. And a value, determine the differential equation. Differential equation here, the y of omega by the x of omega. Multiply here omega square into y of omega means t square y of t. Omega is the first derivative, 5 into dy watt of dt, and 6 y of t, and x of omega into j omega means the derivative function, and 4 into x of omega is a 4x. Okay, and impulse response h of t is equal. By using the partial differentiation expansion method, you can find the h of t. And c is what is the output of s when the input is x of t is equal. The x of t is given this function 1 by 4 plus j omega, and t into means 1 by 4 plus j omega whole square. So y of omega is multiplied with this x h of omega, getting of a and the b values. Again, the y of t is equal. Y of t is equal to 1 by 2 e power minus 2 t mu of t minus 1 by 2 into e power minus 14 to mu of t. What it minus 2? So with this, the completion of the inverse Fourier transformation, and the last topic in this unit is a Hilbert transform. Hilbert transform is the converting of time domain to the time domain of the Hilbert transform. H of t is defined by h cap of t is equal to 1 by pi, the integral minus infinity to infinite, h of tau t minus tau deta. So actually the Fourier transformation is x of omega is equal to, in terms of the x of t. Okay, x of t is a time domain function, x of omega is a frequency domain function. But here, the Hilbert transform is a h cap of t. The Hilbert transform is equal to 1 by pi and integral minus infinite to infinite. The h of tau is a time domain function, the t minus tau deta. Output is also time domain. The inverse Hilbert transform by means of which the original signal h of t is recovered. H of t is equal to 1 by pi, the integral minus infinite to infinite, h cap of tau the deta. The functions h of t and h of t are said to constitute a Hilbert transform pair. H of t and h of Hilbert transform, h of t cap. Both are time domain converted to the time domain. Areas of the signal processing, analysis and synthesis of signals, and design of the filters, etc. To represent the band pass signals, to realize the phase selectivity in the generation of SSB spectrum, SSB system, to relate the gain and the phase of the characteristics of linear communication channels and the filter minimum phase type. The Hilbert transform is converting of time domain to the time domain of t. The h cap of t is equal to same, and inverse Fourier transformation like that, the inverse Hilbert transform is h of t is equal to the same function. Okay.